Alright, so this is part 2 of our 3-6 assignment, beginning here at number 45. So number 45, we're talking about which investment is more attractive, a 5% compounded monthly, or a 5.1% compounded quarterly. And so this is where we would use our annual percentage yield in order to get which one has a higher percent, because we were talking about investment versus a loan. So our APY formula is 1 plus r over k to the k minus 1. And in the first one here, our r is 0.05 and our k is monthly, so 12. And then in the next one, it's an r of 0.051, and we're compounding quarterly. So filling in our APY for the first one, we're going to find 1 plus 0.05 over 12 to the 12 and subtracting 1 versus the APY for the second option, which has 0.051 over 4 to the 4 minus 1. So if we evaluate this first one, this fraction first, then raised to the 12th power, we get 1.00416 repeating that we are then going to bring to the 12th power and then subtract 1. So we get 0.05116. And then for this next one here, evaluating this inner part first, leaves us with 1.0519, but then that being raised, 1.012, that raised to the 4 power is 1.05. And then, of course, subtracting 1 leaves us with 0.05198. So again, we're trying to find which one is the larger number. So 0.5 they both have, 1 they both have, but then this one is 1 and this one is 9. So again, very small, but usually with banks we do use quite a few decimals. So in that case, our 5.1% is best. Alright, and number 7, an IRA account is where Amy is going to contribute $50 per month into the Lincoln National Bank bond fund that earns 7.06% interest, and what is the value of Amy's investment after 25 years. So this is one where we're trying to figure out if it's future value or present value. And so taking a look at it, Amy has $50, but she has 0 at this current moment. And she wants a bunch of money in the end after 25 years. So if we're going to do that one, that means that we're going to have future value because it's 0 now and money in the future. So filling in our pieces here, we have a R of $50 per month. And then we have, what's the next one? R, a rate of 0.0726. We have a K, which is kind of annoying because it's just 1 since it's annually. And then we have our T of 25. So plugging that into our future value, we're going to do 50 here. And then 1 plus our R, 0.0726, divided by 1. That raised then to the 1 times t, which is 25, minus 1 over 0.0726 over 1. Just ain't going to change anything there. Alright. So, to solve this, we're going to do this inner piece first. So 1 plus that fraction. That value then raised to the 25th power, minus 1, divided technically just by 0.0726. And then that 65 value times 50, the investment that she'll be making. So after 25 years, she's going to have $3,283. Okay, so I did that kind of wrong. This is actually supposed to be, I know it says annual interest, but she is contributing $50 per month. So that should actually be a 12, which is in fact going to change quite a few things here. So if we do it that way, she ends up actually with $42,211.46. Because I literally did it and was like, if she just saved $50 per month, she'd be at $15,000. So it seems weird that she would have $3,283. Okay. Anyway, that's our future value. Yay for saving money. Okay. Then the next one here, number 49, Jolinda contributes to a celebrity retirement fund. Jolinda sounds good. That earns 12.4% annual interest, so our rate is 0.124. What should her monthly payments be? So we're trying to find R. If she wants to accumulate a future value of 250,000 in a time frame of 20 years. So again, she has not much now, and she wants money in the future, and so that's going to be your future value equation. It does say that she is doing monthly payments, and so we are going to have a K of 12, and so we'll plug that into our equation. So plugging in our future value of 250,000, that's going to equal the R value, which we don't know because she wants to find her monthly payment. And then we've got 1 plus the rate, which is 0.124 over 12. And then that's going to be to the 12 times 20. Eventually we'll subtract 1 and then have it divided by 0.124 over 12. Alright, so just like the last time, whatever this number is, we'll end up dividing it to this side as well. Alright, so to get that digit, we're going to do 0.124 divided by 12, add a 1 to that, bring it to the power of 12 times 20, subtract a 1, and eventually divide by 0.124 over 12. So we get 1044.22. And so we take 250,000, divide by that number, and we get $239.41 as their monthly payment. Alright, our last few here. What is Kim's monthly payment for a 4-year $9,000 car loan with an APR of 7.95 from Century Bank? So, this is the one where we have money, so they're giving us $9,000 right now in order to pay for the car, and so this is going to be the present value. So it says there's a 4-year loan at $9,000, so T is 4, 9,000 is the present value, and then our rate is going to be 0.0795. Alright. So in the present value equation, we need 9,000, and then that's going to equal the R. We're trying to find out the monthly payment. 1 minus 1 plus our rate, which is 0.0795, over a monthly payment, so 12, equals our K. Bringing that to the negative 12 times T, which is 4 for 4 years. And then all of that divided by 0.0795 over 12. So again, we'll find this digit and eventually divide it into 9,000. So 0.0795 divided by 12 plus 1 brought to the negative 12 times 4. 1 minus that number, and then that solution divided by 0.0795 and 12. So we get 41.0013 that we're going to divide both sides by. So 9,000 divided by the answer that we had, gets us $219.51 for the R. Alright, the last one is house mortgage payment. Gendo, don't know, obtains a 30-year, so that's our time frame, $86,000, so this must be a small house or not in central Minnesota here. So $86,000, and that's going to be the value that they're getting the loan for right now, because technically you pay for the house up front. It's just that the mortgage is who you got that payment from. So anyway, we have money now to pay for it, and now we're going to pay it down. So that's our present value. Oops. And then we have an APR, so our rate is 0.0875. And we're talking about monthly payments, so our K is 12. So, plugging into our present value equation, our present value is $86,000, and we don't know what our monthly payment is. And so we're going to take 1 minus 1 plus R, which is 0.0875 over 12, bring it to the negative 12 times 30. After that, we've got R, which is our rate, over 12. And so we need to find this value so we can divide it. So, innermost parentheses is 1 plus 0.0875 divided by 12. To that, we'll bring it to the power of negative 12 times 30. Then we'll take 1 minus that and divide it by our fraction of 0.0875 and 12. So we get 127.11. And so that value is going to divide into 86,000. And so we get a monthly mortgage of $676.56. That would be a nice mortgage. Okay. Perfect. Not to mention that, oh my gosh, 8.75 is a huge percentage rate, because right now it's like 2.75. Okay, so either way, there we go. So those are the last few problems from 3.6.